Hello students, this is Shiv Mitra. Now we'll discuss some of the proofs of the property which we have not mentioned in the earlier lectures. Now suppose we have property tan inverse x plus tan inverse y, tan inverse y equals to tan inverse x plus y upon 1 minus xy or xy less than 1. And one more thing, one more property, we have pi plus tan inverse x plus y upon 1 minus xy for x greater than 0 and y greater than 0, y greater than 0, comma xy greater than 1. And one more property we have. First of all, we will see the proof of it. Now suppose we have in the case of first case, in this case tan inverse x plus y upon 1 minus xy, xy less than 1. We have xy less than 1. For xy less than 1, what we will do? We will just start assuming that let tan inverse x equals to let tan inverse x equals to alpha and tan inverse y equals to beta. Now what we will get, x equals to tan alpha and y equals to tan beta. Now what we can do, suppose we are going to have a pattern tan alpha plus beta, then we will get the formula tan alpha plus tan beta upon 1 minus tan alpha tan beta. This is the basic tan A plus B formula. So we will get x plus y upon 1 minus xy. Implies that tan alpha plus beta equals to x plus y upon 1 minus xy. Implies that alpha plus beta equals to tan inverse x plus y upon 1 minus xy. This is the result for xy less than equals to 1. Xy less than equals to less than 1, not equal to, only less than 1. Now in next case, we have the x greater than 0, y greater than 0, xy greater than 1. So we'll start when x greater than 0, case second, x greater than 0, y greater than 0. We have the xy greater than 1, xy greater than 1. It means that 1 upon x greater than 0, 1 upon y greater than 0, and 1 upon xy less than 1. Definitely 1 upon xy will be greater than 0 and less than 1, such as 1 upon x, 1 upon y can be written as less than 1. Now we have a case first, tan inverse x plus tan inverse we can write on the place of x 1 upon x plus tan inverse 1 upon y. We can directly use the first case result equals to tan inverse 1 upon x plus 1 upon y upon 1 minus 1 upon x into 1 upon y. Now this can be, result can be reduced to a short form, and tan inverse 1 upon x plus tan inverse 1 upon y can be written as cot inverse x plus cot inverse y. Cot inverse x, I'll put the copy here, cot inverse x, cot inverse y. Now what we will get, we put in the cot inverse x plus cot inverse y equals to tan inverse, by reducing in short form we will get x plus y upon xy minus 1. Now this can be written as a tan inverse, taking minus common x plus y upon 1 minus xy. Now this minus changes the result and we will get pi by 2 minus tan inverse x in a bracket plus pi by 2 minus tan inverse y equals to minus of tan inverse x plus y upon 1 minus xy. Pi by 2 minus tan inverse x plus pi by 2 minus tan inverse y equals to minus of tan inverse x plus y upon 1 minus xy. Because in the first quadrant everyone is positive, we got the minus of 10, so we'll put pi by 2 minus tan inverse x plus pi by 2 minus tan inverse y to get our result. Now what we'll have pi minus 10 pi by 2 plus pi by 2 becomes pi tan inverse x plus tan inverse y equals to, and this pi by 2 minus tan inverse x can be directly is written from here, cot inverse x plus cot inverse x plus tan inverse x equals to pi by 2. We have already studied the formula cot inverse x plus tan inverse x equals to pi by 2. From there we can write cot inverse x equals to pi by 2 minus tan inverse x, and cot inverse y equals to pi by 2 minus tan inverse y, and pi by minus tan inverse x plus tan inverse y equals to minus of tan inverse x plus y upon 1 minus xy. Now this can be result can be reduced in a short form, and this can become tan inverse x plus tan inverse y, and this pi can be transferred to that side, pi plus tan inverse x plus y upon 1 minus xy for x greater than 0, y greater than 0, and xy greater than 1. This is the proof of the required equation. You can go on once again through the video and have the proof in clear manner, so that there should not be any confusion regarding the proof. So we will have the next property. One more case is there, tan inverse x minus tan inverse y, tan inverse x minus tan inverse y equals to tan inverse x minus y upon 1 minus 1 plus xy. I think this can be done very easily by all of you, xy greater than minus 1. This will be done by you as an assignment. GNMENT assignment. Now we will see the next property. We have discussed sine inverse 2x upon 1 plus x square equals to 2 tan inverse x for mod x less than equals to 1. This can be done by assuming that proof let tan inverse x equals to y. Let tan inverse x equals to y, or we can say that x equals to tan y. We can have the condition now for mod x less than equals to 1, means that y greater than equals to minus pi by 4 less than equals to pi by 4. Now we have already mentioned tan inverse x equals to y and x equals to tan y. We will use our term sine inverse 2x using the formula of sine 2y. Sine 2y equals to 2 tan y upon 1 plus tan square y. This can be used and can be written as 2x upon 1 plus x square implies 2y equals to sine inverse 2x upon 1 plus x square for the above condition. Therefore, we have got a result that 2 tan inverse x equals to sine inverse 2x upon 1 plus x square for the above condition. Now, rest of the proof, two more properties were there for this on the same basis, that will be done by you on the basis of assignment. Now we will have one more property. Now we have studied next one, sine inverse x upon under root 1 plus x square equals to tan inverse x. Now proof of the property lies on x equals to 10y that I already have mentioned in that proof. X equals to 10y implies y equals to 10 inverse x for the condition y greater than minus pi by 2 less than y greater than minus pi by 2 less than pi by 2. The problem occurs in covering of the page because when I'm watching the cell phone, the page is diminished from my eyes, and when I'm watching the page, that cell phone camera coverance is diminished from my eyes. So please take care of it. Watch it twice or thrice to get your ideas and clear it. Now we have assumed x equals 10y. This means that under root 1 plus x square can be written as under root 1 plus 10 square y. 1 plus 10 square y. It means that under root of sec square y implies mod of sec y or sec y, mod of sec y equal to sec y. This all can be written into it. Now you know that condition sine inverse x upon under root 1 plus x square equals to sine inverse 10y upon sec y. This can be written as sine inverse 10y can be broken to sine upon cos, and sec y can be written 1 upon cos. This will lead to sine y, implies that y. It means that sine inverse x upon under root 1 plus x square equals to y, and y means 10 inverse x, which gives our result. This is the required proof. Rest of the proofs will be done by you as a assignment. Now we have 3 more properties to prove that we will do in next lecture. Thank you.